Okay, so we've talked a little bit about taking a figure and rotating it about an axis. If you remember from rotating, what we did a couple of chapters ago when we were rotating, reflecting, and translating, we were rotating about a point. So we were staying in the X and Y coordinate plane. So now we are moving into a three-dimensional. So if I am not rotating about a point, I'm rotating this figure about this line. So if I take this triangle and rotate it all the way around, you need to be able to recognize what shape that I am going to be creating. So if I have this shape and I rotate it, I am going to be creating a cone. Let me get a different pen. So let's visualize that. So if I have a cone, okay, so that is a 3D cone. I am actually taking this triangle and rotating it all the way around. So that would be considered part of a cross section, or the 2D figure that is being rotated. Let's look at letters B, C, and D. I want you to pause the video right now and then try those three on your own. Okay, so if you are rotating this rectangle, you are going to get another rectangle over here, but it's going all the way around, so you are creating a cylinder. This one, if I rotate this shape all the way around, it's going to be creating a sphere. And if I have this shape, I'm not even going to attempt to draw this shape, but I can get a good visual. I'm going to call this a donut, or you can think of it as an inner tube. The important thing is that you can visualize taking a 2D rectangle, rotating it all the way around 360 degrees. That would be going in the X and Y and Z coordinate plane and getting that figure. Okay, so we are going to go down here. So we have a cylinder, but it has a cone subtracted from its volume. So that means this cone really isn't there. So what shape would I have to have in order to create this figure? Again, I would pause the video. And that is the shape that you would have. Okay, so if I rotated this figure, it is going to give me a 3D cone right in the center of it. Okay, so go ahead and try this one as well. I would pause the video, and you would get a shape that has a cylinder in the bottom. So I get a cylinder by having a rectangle, and then this would give me my half a sphere or a hemisphere on the top. Okay? What we are doing is, you've all been through one of these revolving doors. But what is actually rotating to create this entire revolving door? You're actually just rotating a door. So that door, once it goes all the way around and is rotating or revolving about this line, this is what you're going to be creating. So hopefully that might give you a better picture of what it is that we are doing. Okay, so I am now on this page of the green packet. The important thing here is to read what is being asked. What does the rotational cross section, so in other words, the rectangle, have to do with the volume? So we are going to be answering some of these questions. So again, I would answer the first two questions and then pause it. So the height of the cylinder, so I'm not talking about the rectangle. I'm talking about if I rotate this rectangle all the way around and create that cylinder, how high is the cylinder going to be? And the answer is 3. And the radius of the cylinder, again, I'm rotating about this axis, so that will give me a radius of 4. Using the volume formula, I can find the volume of the cylinder. Volume equals pi times my radius of 4 squared times my height of 3. And I get pi times 16 times 3, which gives me 48 pi. Okay? So if I'm looking at now, there's the rectangle I'm focusing on. So I'm back into 2 dimension. The height of the rectangle then is 3. The width of the rectangle is 4, and the area is going to be 12. So just make sure that we are on the same page. Okay, we are going to be working on number 1 together. So we're going to do this real quick. And we are going to have to work backwards like we did yesterday. So yesterday or even a couple days ago, we had a circumference, and we had to use the circumference formula backwards to find the radius, and then we used that radius to find the volume. This is going to be very similar to that. So I'm telling you right now that these problems are challenging mainly because of the wording. So you need to be very clear on what you are doing. So given a sphere with a volume of 2,000 centimeters cubed, find the area of the perpendicular cross-section right through its center. So I have a sphere with a volume. So I know that I can pull the radius out of there. So the volume equals 4/3 pi r cubed. The volume I have is 2,000. And then I need to solve for the radius. I can either divide by 4/3, or I can multiply by the reciprocal of 3/4. So the 3's are going to cancel and the 4's are going to cancel. So let's see what I get. Oopsie. And I get 1,500 when I put that in my calculator. And I get pi r cubed. And then from there, I'm still trying to solve for r. So I'm going to divide both sides by pi. So I have r cubed equals 1,500 divided by pi. And I get 477, about 0.46. Now, if this were radius squared, what would we do? We'd be taking the square root of it. Well, I have a 3 here. So now I'm going to be doing what's called the cubed root. And in order to do that, again, I'm teaching you based off of my calculators. You will see if you hit second and then the caret button, you will see this figure. Okay, so this means that if it's not there, that's understood to be a square root. But as soon as I add different indexes, then that is going to be cubed root, 4th root, 5th root, etc. So in order to find the cubed root of this number, I am going to type in 3, and I'm going to get that button, and then I'm going to type in 477.46. So then I'm hitting finding the cubed root of that. I'm going to show you what it looks like. So in my calculator, I am going to hit the 3, get to my cubed root. Notice I have a little x there, and then my root sign of 477.46, and I get 7.82. So my radius is 7.82. Now, we have not answered the question yet. So let's go back up to the beginning now that I have a radius of 7.82. And we are trying to find the area of the perpendicular cross section right through its center. So that means that I have, that is a terrible figure. Let's try that again. Okay, so that means I have a sphere, and I am going to basically doing a karate chop right down the center. So you should recognize that the cross section then would just be a circle, and it has a radius of 7.82, and it's asking for the area of the cross section. This is the cross section. So now I need to go back and figure out how to find the area of a circle. You need to read these questions, like I said, very carefully, and then there is an answer key that for today, so make sure you are following along. Do one problem at a time, and then check your work. I had some people earlier that did 7 and had all 7 of them wrong, so make sure you're checking it as you go.